So let us begin with module 2 of computer networks. The one shot one quite took a long time and wasted a lot of time too. So I'll be making the explanation of the remaining modules in parts. Like if I complete explanation of one topic, I'll simply process and upload directly so that everyone can access to the videos fast and learn for the examination. So topic is error detection correction. So according to the syllabus copy, so here I'll be going one by one with each topic, and at the end I have answers for all these three things, very simple answers with key points and everything. So let us begin. So here now, what is introduction data layer? So first you have to simply define what is a data link layer or error detection correction. Simply whenever the data is being transmitted, sometimes some inference happens, some disturbance occurs. That disturbance will lead to some errors. So correcting that errors and detecting those errors is nothing but data link layer. It's a role. Okay, so that's the definition. If you just read this definition, should be able for you to put in your mind. So first, pause and read then you listen to my explanation should help you for better understanding. So types of error are like single bit and burst errors. As the name says, only one bit is corrupted. Okay, occurs when only one bit in the data is unit is corrupted. Example: a bit 1 changes to 0 or vice versa, 0 changes to 1. For better understanding, you can see this diagram over here. Let me just, okay. So now it's more clear, right? So see here, simply sent, received. This is a corrupted bit. For burst error, samely just draw a long lengthy bit. No need to maintain the order of 0 and 1. It's just random. Don't worry from that. So then just select a range. In that range, just highlight or shade some bits. Not you can either do continuously, leave some gap and say that is corrupted bits. So what is the definition of this burst error is nothing but sometimes like due to some noise disturbance, noise doesn't happen like tuck, just goes off, right? So it happens for a long time. So due to that reason, for a long time the inference. So that's nothing but your burst error occurs when two or more bits in a data unit are altered or more common than single bit errors due to prolonged inference. See, it is more common than single bit error because inference is long, right? You have long inference, interference from other things. So that's why this is more common. Single bit happens because the chance of errors are less here. Only one bit is getting corrupted, and single occur at a time and then leaves, because usually whenever the disturbance occurs, it happens for a long time. The number of corrected bits are dependent on data rate and duration. The rate of data and the noise duration leads to the corruption of bits here. You saw the diagram there. What is redundancy? So redundancy is nothing but to correct a process in which you try to detect and correct the error. Redundancy, see, is the concept of adding extra bits to the data to help detect and correct errors. These bits are known as redundancy. So redundancy is a process in which the extra bits are added to the data, that known as bits, which helps to detect and correct the errors in the data. So sender adds redundant bits to the data, receives the bits to check for errors. So additional point you can mention is, see, added by the sender and removed by the receiver. Okay. Then error detection and correction. Error detection is very simple, where you just have to detect errors. You don't have to mention how many there are or how many bits have been corrupted. You just have to mention how many errors are there. Whereas in correction, you need to know the specific number of errors so that you can work on it and correct it. It is more complex than error detection and requires more information for correcting the errors. So methods you can simply mention. No need to come write like too much, because they won't ask for more than 10 marks. Less than 10 marks only it will be asked. By time if they ask 10 marks, just if you remember these headings like parity check, checksum, cyclic redundancy, CRC, Hamming code, forward error correction, then this is the key points. Here the same thing, detection and correction. So there is a second topic. So here it completes. So let me zoom in properly so for your better view. So now you can see that all are these key points, and now you can simply read these key points and then start explaining. See, you have common methods of checking all the things in short form: error correction, error detection, redundancy, burst error, single bit error. So thank you and see you in the next video.